student. Today I am presenting Sentinel-15, which is an autonomous environmental monitoring and crisis response system I developed in C++. This project represents a fusion of real-time data simulation and automated emergency management. In real-world disaster management, delay between a sensor trigger and a human decision can be fatal. Sentinel-15 is an important project because it automates the decision to action pipeline. It doesn't just watch the disaster. It predicts spread and issues evacuation orders instantaneously, acting as a tireless digital first responder. The primary problem I addressed is environmental complexity. Disasters are rarely isolated. A heat wave can be mitigated by rain, or an earthquake can strike during a flood. Traditional monitoring systems often treat these as separate data points. The problem was, how do we create a unified system that understands disaster interaction and manages the safety of a regional grid dynamically? So, to solve this, I implemented a synchronous cellular automata engine. Let me show you. The system operates on a next map buffer logic. On every cycle, the system takes a frozen snapshot of the current environment. It calculates the state for the next day from the current snapshot. This ensures that the disaster spread is consistent and logical. It uses random num, a user-defined function. It is used for generating random numbers between two values. Here is the function. As you see here, I have used bitwise flags for the alert states. This is a highly efficient way to store multiple concurrent threats, like a flood and a heat wave, in a single variable. I also implemented a negative feedback loop for dynamic equilibrium, ensuring thus simulation maintains a realistic ratio of disasters to neutral space. I have used the shift operator to store multiple threats in a single variable, single enum type. Finally, I want to highlight the proximity logic. A monitor is only as good as its response. Using a Muir-and neighborhood search, Sentinel-15 automatically flags buffer zones around critical disaster epicenters. It proactively issues evacuation orders for neighboring sectors even before they are directly hit. This is the ultimate goal of a system, a faster, smarter, and more truthful way to save lives. It also saves the data in a report as a txt file. The evacuation notices are saved in the file. There are many evacuation notices per day because it is not based on some sample data. The data is generated by a function. That's why it is just for a demo purpose. This can easily be replaced by real data. Thank you for watching.